A charged particle moving along positive x direction with a velocity v enters a region where there is a uniform magnetic field B equal to minus b k cap from x is equal to 0 to x equal to d. The particle gets deflected at an angle theta from its initial path. The specific charge of the particle is. Here magnetic field is in the region between x equal to 0 to x equal to d, and the direction of the magnetic field is negative z direction. Let's say this is the inward direction in the plane of the paper. Now the particle moving along positive x direction, that is in this direction, and when it enters to the magnetic field, then it get deflection 12 angle theta. Now so the magnetic force on the particle is q v b sin 90. Here q is the charge of the particle and v is the velocity and b is the magnetic field. And if the particle rotate in a circular path of radius r, then the centripetal force is m v square by r, where m is the mass of the charged particle and this centripetal force is equal to the magnetic force. So qvb equal to mv square by r. So vb equal to qb by mv by r. So r equal to mv by qb, where r is the radius of the circular path. Now this distance is d and this is perpendicular to this line, so this is 90 minus theta, this angle, and this is also 90 minus theta, so this is 90, so this angle is theta. Now OPQ, so from triangle OPQ, sin theta is equal to d by r. So r equal to d by sin theta. So from equation 1 and equation 2, d by sin theta equal to mv by qb, and now specific charge, that is q by m, is equal to v sin theta by bd. So the option D is correct.